as I said before, we've been used to rounding to decimal places. So here we're rounding to 1 decimal place, 2 decimal places. I just went through this. However, today we're going to look at rounding to significant figures. So another way of rounding is to give the most relevant or important digits of a number. For example, if you're at a football game or something like that, Allianz, maybe the grand final, the crowd might be 89,123, but, you know, if you were just saying that, if you want to give a quick idea of how many people were there, a rough idea of what the crowd was, we would say 89,000. Now, this is only given to 2 significant figures. Okay, so I'm only worried about the first 2 figures, 89. It's roughly 89,000. Another similar example would be the population of Australia, which is, does anyone know what that is closest to? 23 million. We know it's exactly not 23 million. It could be 23,200,000 and whatever thousand, etc. But we're rounding that 23 million just to 2 significant figures, the 2 and the 3 of the 23. Then we're filling the rest of the spots in with zeros. They're significant. So when we say Australia's got 23 million people, that's only given to the nearest million, but 23 million, we've got 2 significant figures and the other zeros just fill in place value. So when we look at science and engineering, for example, some digits in numbers are considered important or significant. In such cases, we are able to round numbers within a certain number of significant figures. So when we look at science and that, we round often to sometimes decimal places, but for really small numbers or really large numbers, we round to a certain number of significant figures. So we use significant figures to indicate the size of a number by writing it to the nearest 1, 10, 100, 1,000, or to the nearest tenth, the nearest hundredth, or the nearest thousandth. For example, when we talked about, so you've got to round to the nearest unit, the nearest 10, the nearest 100, the nearest 1,000, or we'll round off to the nearest tenth, which is 1 decimal place, the nearest hundredth, which is 2 decimal places, the nearest thousandth, which is 3 decimal places. But I'll explain to you in a minute the difference between significant figures and decimal places. So in our example above, 89,123, that's written to 1, 2, 3, 4, 5 significant figures, but when we round it to 89,000, it's rounded off to 2 significant figures. Now, before we round to significant figures, we need to define what a significant figure is. So, these are the rules. When rounding to significant figures, the first significant figure in a number is the first non-zero digit. So, what's the first non-zero digit in my first number? Okay, what's the first non-zero digit in this very small number? So can you see why the second number, why would you not round that to 1 decimal place? What would you get if you rounded this to 1 decimal place? 0.0. If you rounded it to 2 decimal places, 0.00. If you rounded it to 3 decimal places, 0.000. It's not telling you anything. But we're going to learn to round to significant figures. So the first significant figure is 2. Do you know how many significant figures there are in this number? 3. Okay? So that's why in science, to take care of whether a number is very large or very small, they'll tell you to round to a certain number of significant figures instead of decimal places. It doesn't matter then if the number's really big or small. Okay? So, the first significant figure is the first non-zero digit. Zeros, second rule, zeros at the end of a whole number or at the beginning of a decimal are not significant. Now, look, sometimes they are actually, sometimes they're not, all right? But the zeros, see the zeros at the end of a whole number, so these may or may not be significant, it depends. If we counted the number of people and we got exactly 1,340,000, then all of those zeros are significant. I mean, who said you can't count 100 people, all right? But if I had 1,341,982, and I rounded it to that, then these zeros are not significant. They're just place value holders. Now, you'll know in the context of a question whether the zeros at the end of a whole number are significant or not, all right? Now, so the zeros at the end of a whole number or at the beginning of a decimal, see these zeros at the beginning? They're not significant because what's the first significant digit? The 7. Remember, the first significant figure in a number is the first non-zero digit. Zeros at the beginning of a decimal are not significant. I've got nothing in the tenths column, nothing in the hundredths column. Look at this decimal. There are no tenths, no hundredths, 7 thousandths. That's my first significant digit. Why would those zeros be significant at the beginning? There's nothing there. No tenths. That's the tenths column. That's the hundredths column. There's none. Okay, now, zeros between non-zero digits or zeros at the end of a decimal are significant. Now, I'll explain what that means. So in science, right, so this zero in the middle is significant, but the ones on the end may not be. See, if in science, this is why in science, let's say you measure something and it was 0.2, and that's all you know the accuracy to. But if you start putting all these zeros at the end of your decimal in science, then you're telling the teacher and everyone else that you've measured it to that accuracy. And you probably haven't, okay? So zeros at the end of a decimal are significant. So if you only know it to that accuracy, don't go throwing a whole heap of zeros at the end of your decimal. All right? Okay, so the zeros in between, of course, are significant. They're just another number there between that 6 and 8. This 0 is significant. But in science, do not just keep putting lots of zeros on the end of your decimals because you're telling them you've measured it to that accuracy. All right? So, for example, let's say I measured the length of something to 1.5 centimeters. And that's all I measured it to. It's 1.5 centimeters. Can I write that in meters? How do you write that in meters? How do you convert centimeters to meters? Divide by 100, 0.015. That's okay, you know it to that accuracy. But if you start throwing zeros on the end, then you're saying that you know it to even more accuracy, which you don't. So if you know it's just 1.5 centimeters, you don't go writing 1.50. See, when you write 1.5 centimeters on a ruler, your measurement could have been 1.46, but you decided to round it to 1.5. Do you understand what I'm saying? 1.47, 1.48, 1.49, we're going to round them all up to 1.5. But if you write 1.50, then you know it's exactly 1.50. But if I just write 1.5, it could have been 1.46, 1.47, 1.48, 1.49 rounded up to 1.5, or it could have been 1.51, 1.52, 1.53, 1.54. So if you go and put 1.50, then you're telling me, Miss, it's not 1.52. I know it's exactly sitting on the 1.5. If you're writing 1.50. Do you understand what I'm saying? When you decide roughly what it is, you never roughly get 1.5. You say it's closest to 1.5, unless it's sitting exactly on it. Now, you'd need a much more accurate measuring instrument than a ruler to be able to put 1.50. All right? There are instruments that do that, but you don't have it. Your ruler, 1.5 would be the most accurate you can give me. So if you're measuring something 1.5 centimeters, you do not write 1.50 because your ruler does not allow you to measure to that accuracy. All right, let's look at these. How many significant figures do we have? What do you think? They're all numbers. 3. Are zeros at the end of a decimal significant? Zeros at the end of a decimal are significant. So if you write 63.7, then you're really telling me, Miss, it's somewhere between 63.65 and 63.74. Do you understand what I'm saying? If you're telling me 63.70, you are telling me it is exactly 63.70. I know it's not 63.71 or 72 or 69. How many significant figures? 4. Zeros at the end of a decimal, if you write them down, you're telling me I know it to that accuracy. What about this one? 5. Zeros at the end of a decimal are significant. So girls, if it's 63.7, just write that, unless you know it's 63.7000. Do you understand what I'm saying? Now, what about these others? How many significant figures? 3 there, because 3 is the first significant figure. This one here, we think it's 2. Or zeros at the end. 2, definitely. It's a minimum of 2. I don't know what this number was. Let's say my number was 7604. And I rounded it to that 7,600. Can you see I've rounded it to, well, can you round that, if I round that to 2 significant figures, I'd get 7,600. Actually, no, I'm going to do this one. Oh, no, don't worry. I'll do it on the next page. I'm going to confuse you. I ask you to round 7599. If I ask you to round that to the nearest 100, what would you get? To the nearest 100. Can you round that to the nearest 100? Good. Can you round that to the nearest 10 for me? I want you to round it to the nearest, to the tens column. 7,600. Can you see that? So that's why I'm saying if I ask you to round to the nearest 10, you're actually rounding to 3 significant figures. And if I actually have the number 7,600.2 and I ask you to round that to the nearest whole number, what would you get? So that's rounded to 4 significant figures. So when you see 7,600, yes, we first will assume it's only to 2 significant figures, but there could be cases when it's rounded to 3 significant figures, like this case here. Or if it's a decimal, it could have been rounded to 4 significant figures. So sometimes it's a bit hard to tell with a whole number. All right? This is our rules to round numbers to a specified number of significant figures. First thing you do, find the first non-zero digit counting from left to right. Then from the first significant digit, count the number of significant digits, including zeros. Stop at the required number of significant digits. You have to round the last digit. You'll see what I mean in a minute. And replace any non-significant digit to the left of a decimal point with a 0. Now, when I do it, I'll tell you which rule I'm using. First thing, write each of these numbers to 3 significant figures. Is that significant, the 4? Is the 7? All right, I'm only allowed one more number. So 47 point, I'm only allowed one more figure, 7. Do you go and put all the zeros in at the end? No, because if you do, then you're telling me you know it to that accuracy. Remember, zeros at the end of a decimal are significant. So if I want 3 significant figures, I just want 3 numbers here. What about the next one? 91.5. That's 3 significant figures. But be very careful with the next one. Is 2 significant? 7, 3. What am I going to do with that 200? Now, what am I going to put in place? So you're saying there were 273,200 people, and you can't round that off to 273 people. That's approximately 270. You've got to fill in the place value. It's like the game of football. 89,123 people. That's roughly 89,000 people. 273,200 is approximately 273,000, rounded to 1, 2, 3 significant figures. Of course, zeros at the end of a whole number have to be put there to keep place value. I can't say 273,200. I'm going to round that off to 273. No, you say that's approximately 273,000. Do you get what I'm saying? It's like the population of Australia. 23 million, whatever it is approximately 23 million. We don't say Australia, if I ask you to round Australia's population to two significant figures, you don't tell me, Miss, Australia's population is approximately 23. You tell me 23 million. You've rounded it to the 23 and you fill in the rest with zeros. Okay, the next question. Write each of the following correct to one significant figure. Are the zeros at the beginning significant? No. So 0.00, I'm allowed one digit, 8. Good. The next one. The zeros at the beginning are not significant. 0.00, I'm allowed one digit. Be careful with the last one. 0. Well, I don't. I need to change that 9. So what do I get? 1. If I put 0.0, then that's two significant figures. Zeros at the end of a decimal are significant, so it's just 1. So I'm going to put the 0, but that's wrong. I've got to cross it off. Because 1.0, zeros at the end of a decimal mean something. You're telling me you know it to that accuracy. So I'm only allowed one number, 1. See, look, the zeros at the beginning just tell me place value. There's my significant figure, the 8. There's my significant figure, the 4. 1 is already my only figure I'm allowed. It's different if it's 100. I need the zeros to retain my place value of 100. You're going to see it here now. No, 2.5. We're still deciding on that 3. What do you becomes a 4? Yep, no more zeros at the end. Girls, you'll see with the whole number how it's different. 0.00271. 3 significant figures. The zeros at the beginning only tell me place values. The first significant figure is the first non-zero digit. What are these zeros doing here? They're just telling me no tenths, no hundredths. Rules is rounding, but tell me how many decimal places I've got there. 5. How many significant figures? The zeros at the beginning of a number are not significant. 2 is my first significant figure, then 7, then 1. 3 significant figures. The next one, 568,810. 560, so you tell me, Miss, that's approximately 569,000. You don't, see, the zeros have to be put here. Otherwise, you can't say 568,810, that's approximately 569. Full stop. No, it's not. It's just, it's almost 569,000. Okay. Effect that truncating or rounding during calculations has on the accuracy of results. Rounding off is used to approximate a number to a value that is easier to use but close to the real value. For example, 4.26, if we round that to one decimal place, it's 4.3. Now, truncating, now there's difference between rounding off and truncating. Truncating cuts off part of the number's value. It is the same as rounding down. If I truncate 4.26, it's 4.2. I cut off the last digit. Now, obviously, sometimes that's not very accurate, is it? Because we know that 4.26, for example, is closer to 4.3. But if I truncate, I cut the last digit off, or how many ever I need to. Now, girls, when calculating the answer to a problem with more than one step, do not round off until the final step. You all know that already. Rounding during a calculation can cause greater inaccuracies. So 2 students were asked to multiply 3.56 by 4.73 and express their answers to 2 decimal places. Here are their methods. Well, first student rounded off 3.56 to 3.6, rounded off 4.7 to 4.73, to 4.7, and then did the multiplication and got that. And this other student B did not round off, got this answer to 4 decimal places, and then rounded off. Who's the most accurate? Student B. Why? Because student A rounded off before the calculation. So student B is most accurate. Please don't do what student A did. Student A rounded off before the calculation. Notice the answers are quite different, okay? In this next section, we're looking at why measurements are never exact, and we're going to look at the accuracies of measuring instruments. And what the accuracy of a measuring instrument is plus or minus half the smallest unit. Now, let's look here at this caterpillar. Now, I know it's a bit blurry. Shh. Now, if we get a ruler, see, you've got to decide, you're going to have to round off, and you're going to have to decide how long this caterpillar is. Now, the caterpillar is, all right, how long is the caterpillar to the nearest centimetre? To the nearest centimetre? Or to the nearest millimetre? Well, I don't even think he's exactly 3.2, but to the nearest millimetre, he's 30 what? 32. Shh. Shh. So the caterpillar, girls, is 3 centimetres long to the nearest centimetre, or 32 millimetres long to the nearest millimetre. With any instrument, the limit of how accurate you can be is plus or minus half the smallest unit. What made us decide on 3? Because it's less than. So if our smallest, girls, if the smallest unit is 3, this is when you decide to say 3, isn't it? If it's less than 3.5 or 2.5 or more. So there's 1 centimetre from 3 to 4. Halfway is 3.5 and halfway is 2.5. You decide to say 3 when you lie from 2.5 and above and less than 3.5. Is that correct? So you're doing half of 1 centimetre on either side. That's what I mean by plus or minus half the smallest unit. Let's look at this. For example, a man is told he is 173 centimetres tall. I'm sure that when we measured him, he doesn't have to be exactly 173. He could have been anything from 172.5 to less than 173.5. That's if I want his measurement to the nearest centimetre. If he's 172.7, I'm going to say 173. If he's 173.4, I'm saying 173. So, let's look at the importance of significant figures in a given measurement. So, the number of significant figures in a measurement indicates the degree of accuracy. When you go throwing all the zeros at the end of a decimal, you're telling me I know that it's this accurate, when often you don't know. So, if you tell me the answer is 1.3 metres to 2 significant figures, then the real length lies between 1 point what and 1 point what? 1.25 and 1.35. Do you get that? If you tell me 1.30, just look at the 30. When do you decide? I'm going to cover the 1 point. When do you decide that something's 30? When it's bigger than 29.5 or smaller than 30.5. So that's between 1.295. So I've got to go one more figure. And 1.305. So the answer is not 1.29 or 1.31. See, when you write 1.30, you're telling me it's not 1.29 and it's not 1.31. So if it's not going to be 1.29, it must be bigger than 1.295 or more, and it must be smaller than 1.305. The last one, 1.300. No. When I write 1.300, you're telling me it's that accurate. You're telling me it's not 1.299 and it's not 1.301. Tell me what it must be. 1.2 1.995, bigger than that, or smaller than 1.3005. Okay? All right.